Welcome to Mrs. Hunton's First Explain Everything. We're going to do KA more SVA math. Before this, we have done SVA math and not included direction. In this KA, we will talk about how to add a sense of direction. So read along with me. Velocity or speed with direction. Velocity is a vector quantity that includes direction as well as speed. In the case of motion along a straight line, we can describe the direction with a plus or minus sign. Assume that we measure distances from west to east, as is done by the mile markers along the interstate highways. We then say that something moving east has a positive velocity and something that moving west has a negative velocity. We can calculate the change in velocity by taking the difference of the final and initial velocities, including their signs. So if you will recall, never eat shredded wheat. If something is going east, we will call it positive, and if something is going west, we will call it negative. Okay, let's move on to the next slide. When is the change in velocity? What is the change in velocity that occurs when a car traveling at 25 meters per second east turns around and travels 15 meters per second west? Okay, so just as always, we identify our variables. So what is the initial velocity? It would be VI equals 25 meters per second. And this is east, so we said that east is positive. The final velocity is traveling west, so we would make that negative. So that is negative 15 meters per second west. And we are asking for the change in velocity, so delta V equals question mark. And we know that the formula for the change in velocity is the final velocity minus the initial velocity. And here's where you have to be careful. You need to put in the substitution VF and VI just as is, including the sign. So that would be negative 15 minus positive 25. And a negative minus 25 equals negative 40. So the change in velocity is negative 40 meters per second. And of course, we could be asked, what direction is that traveling? And the answer would be west, because it is in the negative direction. Okay, let's move on to the next slide. What is the change in velocity of a car traveling westward that speeds up from 40 kilometers per hour to 60 kilometers per hour? So the process is the same. The initial velocity, 40 kilometers per hour, and I ask myself, is that positive or negative? We said that west is always negative, so that would be minus 40. And since the final velocity is also going west, it would also be negative. So the final velocity is negative 60 kilometers per hour. And we want to find the change in velocity. And of course, the formula is the final velocity minus the initial velocity. So we do our substitution, and that would be negative 60 minus negative 40 kilometers per hour. And perhaps you've been taught before, if you have minus a minus, you circle those and those become a plus. So that would be negative 60 plus 40. And you can do it in your calculator also to verify. Minus 60 minus negative 40 will be negative 20. The units are, be careful, kilometers per hour, and the direction would be west because it is negative. Okay, the next one. Suppose a ball is traveling at 10 meters per second in a direction that we decide to call positive, and that 6 seconds later it's moving in the opposite direction at 20 meters per second. What is the average acceleration of the ball? I'm going to write A first because I'm looking for the acceleration. And 10 meters per second they said was positive, and I say meters per second is a unit of velocity. So is that my initial velocity or is that my final velocity? From the context of the problem, I see that it's the initial because 6 seconds later, which is delta t, it is traveling at a velocity of 20 meters per second in the opposite direction. Since the initial direction was positive, the opposite direction must be negative, and we're looking for acceleration. I know that the formulas are acceleration equals delta v over delta t, the change in velocity over the change in time, and the change in velocity is defined as vf minus vi. So I ask myself, which formula am I going to use first? And I think I will use the delta v equals vf minus vi first because I know both the final and initial velocity. So delta v is, and this is where I have to be careful with my signs, minus 10. And I know that negative 20 minus 10 equals negative 30 meters per second for delta v. Now I can add that into substituting for A equals delta v over delta t. So I have negative 30 meters per second divided by 6 seconds. And I ask myself, how many times does 6 go into 30? And 5 times 6 is 30, so that would be negative 5. And the units are meters per second, so meters per second squared. So notice that acceleration is also a vector quantity, and it can also be negative. Okay, now that you've had some sample problems, try to complete the rest of this KA on your own, and we will give you the answers when you return to class.